Students, now we are on the topic quadratic expressions objective. In the quadratic expressions objective topic, we are discussing the concept of location of roots. In the concept location of roots, Roman number 1 completed depends upon a real number k. If k greater than both roots alpha and beta and k less than both roots alpha and beta and k lies between the both roots alpha and beta, like that three concepts, three cases we discussed with the graphs and everything. Now let us discuss about example depends upon the condition for the number, condition for a real number k, page number 58 concept. Level 2 class work 38 is there. Level 2 class work 38 depends upon the question, that concept. Level 2 class work 38 question is there. So page number 71 in our material, page number 71, level 2 class work 38 question. The set of values of p for which 6 lies between the roots for the equation. Given QE, let us write given QE. Given quadratic equation f of x is equal to x square plus 2 into p minus 3 into x, 2 into p minus 3 into x plus 9 is equal to 0. X square plus 2 into p minus 3 into x plus 9 equal to 0. This set of values for p for which 6 lie between the roots. 6 lie between the roots. So condition is alpha less than 6 less than beta. So alpha less than k less than beta concept. For that condition we have discussed, I think, a into f of k less than 0. There we have discussed condition for a real number concept, condition for a real number concept. A greater than 0, just we can verify condition, page number 58 concept, k lies between the roots. We got there a into f of k greater than 0. A into f of k greater than 0. First one, yeah, we got it less than, because alpha minus 6 minus alpha greater than 0, 6 minus beta less than 0, plus into minus minus. So a into f of k less than 0, first condition. Next, there is no relation between k and minus b by 2, already we had written, and delta greater than 0 only because two distinct roots should be exist. So depends upon this, so we can say. What is k here? Here k means 6. So substitute here a into f of 6. So f of 6 less than 0. So it becomes 36 plus 2 into p minus 3 into 6. 12 into p minus 3. 12 into p minus 3 plus 9 less than 0. So 36 plus 12p minus 36. 36 and minus 36 will be getting cancelled. 12p plus 9 less than or equal to less than 0. You can write this one p less than minus 9 by 12. So minus 3 by 4. And delta greater than 0 I am writing. Delta greater than 0 means here you can write 4 into p minus 3 whole square minus 36 greater than, divide with 4. You can write p square minus 6p plus 9 minus 9 greater than 0. 9 and 9 will be getting cancelled. P taken common, p into p minus 6 greater than 0. So you can write p minus 0 into p minus 6 greater than 0. So p, that means p does not belongs to closed interval 0 comma 6, p less than 0 comma p greater than 6. According to option common domain I am writing here minus 3 by 4. Minus 3 by 4 is lesser than 0. This like put here 6. This is 6. This side and this side. So according to option common domain we can write. According to option common domain you can write minus infinity comma minus 3 by 4. Union 6 comma infinity you can take, but just once we can verify only minus infinity comma minus 3 by 4. So option 2 is verified. Students can get a doubt that here only verify sir, why you should do all these things, no need sir. So you can think like the students, but this is advanced question. In advanced 100% we should verify whether the value is existing here, or if two options are there for this one minus infinity comma minus 3 by 4 u the m 6 comma infinity. This is right, this is right, like that. For multi options or for 6 gamma infinity case, if we verify that it is 6 is not possible, like that also 100% we need this calculation. So don't get confused, this is necessary. Now let us going to discuss about the location of roots for two real numbers k1 and k2. First model completed, only one real number. Now let us discuss for two real numbers k1 and k2. Let us write Roman number 2 concept. Location of roots. If f of x is ax square plus 3x plus c is equal to 0 is a quadratic equation, comma, if alpha comma beta are the roots, if alpha comma beta are the roots of f of x, where alpha less than beta, if there exist two real numbers, if there exist two real numbers k1 comma k2, if there exist two real numbers k1 comma k2, such that among them cases are there, such that first one k1 both roots are y between alpha and beta, and k1 less than alpha less than k2 less than beta, like the three cases may arise, such that I am writing here k1 less than alpha less than beta less than k. That is, both roots lie between k1 comma k2. Both roots lie between k1 comma k2. Now that implies we need to discuss here about k1 separately, k2 separately for two roots, k1 minus alpha less than 0, and depends upon this one k1 less than beta. Now k1 less than beta, so k1 minus alpha less than 0, so k1 minus beta less than 0. You can discuss here k1 minus alpha into k1 minus beta, minus into minus becomes positive. So you can write a into f of k1 greater than 0. This is the first condition. A into f of k greater than 0. Next, for k2 you write alpha minus k2 less than 0 here. According to this one, alpha minus k2 less than 0 and beta minus k2 is also less than 0. So you can write here k2 minus alpha greater than 0 and k2 minus beta also greater than 0. That implies k2 minus alpha into k2 minus beta greater than 0, plus into plus. k2 minus alpha into k2 minus beta greater than 0. You can write here a into f of k2 greater than 0. Therefore, we can conclude that a into f of k1 into f of k2 greater than 0. This is a property. Now, let us discuss about discriminants and everything. Let us draw the graph. If a greater than 0, I am discussing. Whenever a greater than 0, we know that the graph of the quadratic expression is upward parallel. Draw like this. This is alpha. Okay. Put here this is alpha. This is beta. Now this is k2. This is small value. This is k1. You can write here, this is minus b by 2a comma minus delta by 4a. The concept minus b by 2a comma 4ac minus b square by 4a. So k1 and k2 here, this is all. Here f of k1, this is f of k2. So we can say that here k1 less than minus b by 2a less than k2. Whenever k1, k2 are there, you can write here delta greater than or equal to 0 also, because k1, k2 are two real numbers not existed between. So delta greater than equal to 0. It is a choice. Now this is first graph. Let us write the second graph. A less than 0 concept. Whenever a less than 0, the graph of quadratic equation is downward parabola. We are discussing about k1, k2. K1 less than alpha less than beta less than k2. This is k. So here this is the point minus b by 2a comma minus delta by 4a. Here also you can say simply the concept delta greater than or equal to 0 and k1 less than minus b by 2a less than k2. Now using this concept, we have a sum level 2 plus both roots lies between k1 and k2. Okay, first concept depends upon Roman number 2. First concept level 2 class 39 questions. Level 2 class of 39 question, page number 71 in our material, page number 71. All the values of m for which both roots of equation are greater than minus 2 but less than 4. The quadratic equation given as x square minus 2mx plus m square minus 1. Given QM, right? Given quadratic equation x square minus 2mx, x square minus 2mx plus m square minus 1 is equal to 0. X square minus 2mx plus m square minus 1 equal to 0. Here k1 means minus 2 and k2 meaning is 4. That implies the condition is minus 2 less than alpha less than beta less than 4. Read the question. All the values of m for which both roots of this equation are greater than minus 2 but less than 4. Okay. So that condition is minus 2 less than k, alpha less than beta less than 4. They use this one, the concept. Whatever the concept now we have discussed. A into f of k1 equal to 0 and a into f of k2 equal to 0 are both also we will decide. If we both we conclude we should use wavy curve. So better to do separately. Now use f of minus 2 greater than 0. Substitute here, it becomes 4 plus 4m. 4 plus 4m plus m square minus 1 greater than 0. So you can write here m square plus 4m plus 3 greater than 0. M square plus 4m plus 3 greater than 0. You can write here m plus 3 into m plus 1 greater than 0. So m does not belongs to closed interval minus 3 comma minus 1. M less than minus 3 comma m greater than minus 1. Keep aside. And you write here f of 4 also. F of 4 greater than 0. Substitute here, it becomes 16 minus 8m plus m square minus 1 also greater than 0. So next step m square minus 8m plus 15 greater than 0. You can write that one m minus 3 into m minus 5 greater than 0. So m does not belongs to 3 comma 5 closed interval. That meaning is m less than 3 comma m greater than 5. Next, also the condition minus 2 less than minus b by 2a. What is minus b by 2a here? 2m by 2 less than 4. So minus 2 less than m less than 4. Depends upon all the conditions. You can write common domain. Taking a real number graph. Take common domain here minus 3. Put here minus 3. Put here minus 2 and minus 1. And the values, critical points are writing. And 3 and 4 and 5. M less than minus 3, like this. M greater than minus 1, put like this. Minus 2 and 4, put like this. And M greater than 5, put like this. So this is S point. What is S means? The common domain of the given function is here minus 1 comma 3. So according to option 39th question, first option. Yeah. So we write that is equal to minus 1 less than m less than 3. Minus 1 less than m less than 3, option 1. We are discussing the location of roots for the two real numbers alpha, two real numbers k1 and k2. If k1 and k2 are two real numbers existing, for the quadratic equation ax square plus bx is equal to 0, we have discussed now. First one as k1 less than k2 less than alpha less than beta. In second row, second one. In the similar way, let us see the case k1 less than k2 less than. We have discussed now. K1 less than, both roots are lies between K1 and K2. Now, K1, K2 lies between roots. Okay. If K1 comma K2, K1 comma K2 lies between roots. Lies between the roots alpha comma beta. K1 comma K2 lies lies alpha less than, that meaning provided already we said alpha less than beta. Here you can try to understand if whenever two real numbers are there, first one is big, the second one is small, or first one is small, the second one is big. So we can think this one k1 is small and k2 is big. Alpha less than k1 less than k2 less than beta. Okay. Now taking this one alpha minus k1 less than 0. Same in the similar way, alpha minus k2 less than 0. That implies you can write k1 minus alpha greater than 0. You can write k2 minus alpha is also greater than 0. Multiply the both equations. You can write k1 minus alpha into k2 minus alpha greater than 0 plus into plus. Keep aside. Now you can write depends upon k1 alpha. For single alpha should not add. K1 minus alpha and k2 minus alpha should not add. For alpha and beta separately should consider. So alpha minus k1 it's okay. Alpha minus k2, k1 k2 should not discuss like this. So for k1 you should write beta also. It's okay. Alpha minus k1 it's okay. Since alpha less than beta. Since alpha less than beta. Here alpha minus k, of course k1 less than beta. Directly you can write no need. K1 less than beta. So you can write here k1 minus beta less than 0. Yeah. Now alpha k1 minus alpha greater than 0 and k1 minus alpha into k1 minus beta became here plus into minus. Therefore you can say here a into f of k1, a into f of k1 less than 0. It is the first case. Next, for k2 you write now alpha less than k2 you write and k2 less than beta. I think same way, alpha less than k2 and k2 less than beta. So alpha minus k2 less than 0. You can write here k2 minus alpha greater than 0. Here k2 minus beta less than 0. That implies multiply the two values K2 minus alpha positive and K2 minus beta negative. K2 minus alpha into K2 minus beta plus into minus becomes minus. Therefore, A into F of K2, A into F of K2 less than 0. Now, if you multiply the both equations, you can write. So, for using wavy curve, I am discussing it. A into F of K1 into F of K2 greater than 0, because here we have simple as minus into minus concept. Now, let us draw the graph. If A greater than 0, whenever A greater than 0, the graph is upward parabola. Draw like this. Here put alpha, put beta. Now K1 and K2 lies between the alpha and beta. Where the value exists, we cannot say. That is why there is no relation for with minus d by 2a. That also I am writing. There is no relation. There is no relation for K1 comma K2 with minus b by 2a. We cannot decide, simply leave it. But whenever K1, K2 are two numbers, real numbers, alpha and beta are two real numbers, we can conclude that delta 100% two distinct roots should be exist, delta greater than 0. That's all. Next, if A less than 0, if A less than 0, the graph is downward parabola, and put here alpha and put here beta, simply here K1 and K2. Here also the same concept, delta greater than 0. The concept is here for both A into F of K1 to F of K2 greater than 0. If you take separately, you can say A into F of K1 less than 0, A into F of K2 less than 0. Now, I think depends upon this question, this concept level 2. 40 question is there. Level 2, question number 40 is there. Level 2, 40. I think page 71. Page 71, level 2, 40 question. Page 72. Page 72. Read the question. If A belongs to R, if A belongs to R, the roots of this question lies between the roots of this one. Roots of x square minus 2x minus a square plus 1 equal to 0 lies between roots of first equation lies between roots of second equation. X square minus 2 into a plus 1 into x plus a into a minus 1 equal to 0. So first of all, we need to calculate roots of first QD. Here this is 1 and this is 2. Roots of first equation lies between. So the meaning is that roots of first equation are K1 and K2, and alpha beta are the roots of second quadratic equation. For 1 I am writing. For first quadratic equation, you can write x square minus 2x plus 1 is equal to s. So I am writing here x minus 1 whole square equal to s. So x minus 1 is equal to plus or minus a. Therefore x minus 1 is equal to plus a comma x minus 1 is equal to minus a. Therefore x is equal to 1 plus a comma x is equal to 1 minus a. You can understand here k1 is equal to 1 minus a. Yeah, because it is like a small letter. K2 is equal to 1 plus a. Now use the concept. Use f of k1 less than 0 comma f of k2 less than 0. Of course, a into a means here only 1 for all numbers. For second equation, you write for second equation. So you write 1 minus a whole square. 1 minus, first we can write this 1 minus a whole square minus 2 into a plus 1 into 1 minus a plus a square minus a less than 0. Expand this question. 1 minus a whole square. You can write 1 minus 2a plus a square. Yeah. 1 minus 2a plus a square minus 2 into this is 1 minus a square. So this is the plus 2a square. Minus 2 plus 2a square plus a square minus a less than 0. Here a square and a square. You can write 4a square. 4a square. 4a square minus 2a minus, this is minus 3a plus 1. No, minus 1. 4a square minus 3a minus 1 less than 0. By splitting the middle term, we can write here 4a square minus 4a plus a minus 1 less than 0. 4a taken common, it becomes a minus 1 plus 1 taken common, it becomes a minus 1 less than 0. You can write this one as 4a plus 1 into a minus 1 less than 0. So, according to exponent simplified exponents with a concept, you write a belongs to minus 1 by 4 comma 1. Yeah, this is less than your concept. Option is there. No, verify. Minus 1 by 4 comma 1 option is there. 40 question. Second option we got. And also you can write f of k2. Also you can write f of k2. What is k2? 1 plus a. F of k2 less than 0. So here 1 plus a whole square. 1 plus a whole square minus 2 into, for this one, 1 plus a into 1 plus a, you can write 1 plus a whole square plus a square minus a less than 0. Here 1 plus a whole square minus 2 into 1 plus a whole square becomes minus of 1 plus a whole square. A square minus a minus of 1 plus a whole square less than 0. A square minus a minus 1 minus a square minus 2a less than 0. A square will be getting cancelled. Minus 3a minus 1 less than 0. So multiply with this one, it becomes of a plus 1 greater than 0. So a greater than minus 1 by 3. Here minus 1 by 3. So common denomination calculate. There is no relation for minus 3 by 2a. And a less than 0. Simply delta greater than 0. We use this. Also delta greater than 0 for this equation. 4 into a plus 1 whole square. 4 into a plus 1 whole square minus 4 into 1 into a minus 1 greater than 0. 4 divided with 4, it becomes a square plus 2a plus 1 minus a square plus a greater than 0. A square get cancelled. Same concept we got, friends. A greater than minus 1 by 3. Let us write about common domain. Common domain. Draw like this. It is indicating that a greater than minus 1 by 3, meaning is a belongs to minus 1 by 3 comma infinity. And here it is indicating minus, the value should lie between minus 1 by 4 and 1. So here you write minus, friends, minus 1 by 3 is 0, minus 0.33 and minus 1 by 4 is minus 0.25. So minus 0.33 is lesser than minus 3, minus 0.33 and minus 0.25. Minus 0.25 is great. So minus 1 by 4. This is less. Now another one. So it is correct. That's all. No need. So common domain is common domain is equal minus 1 by 4 comma 1. Now you can say here option is second option, 48th question. Option is second option. This is okay. Now another case is there for the location of roots. For the location of roots, another case is there. The another case we can say that depends upon the K1 K2 concept. We discussed in previous Roman number 2 location of roots concept. K1 K2 lies between two roots. Now K1 K2 lies just now we got this one. And in previous 11th class of 39 we have discussed about alpha beta lie between K1 K2. Now let us discuss about K1 and K2. K1 less than alpha, like that we can think. K1 less than alpha less than K2, like this. Given only two conditions. Now let us discuss next condition also. Third one, if K1 less than alpha, less than K2, less than beta. Of course, it did not give, I think, K1, condition for K1 less K1, K2. First condition, exactly one root given. Exactly one root between lies in the interval. That is the concept. Exactly one root. This means exactly one root. Given the concept. Exactly one root lie between. Exactly one root lie between alpha comma beta of QE. I am writing f of x equal to 0. Exactly one root lie between alpha and beta. K1 less than, right, cases now. K1 minus alpha less than 0. We should discuss about K1 separated and K2 separated. K1 minus alpha less than 0. And here it is indicating K1 minus beta less than 0. So multiply both. K1 minus alpha into K1 minus beta. K1 minus alpha into K1 minus beta greater than 0. This is first condition. You can understand this one as A into f of K1 greater than 0. For K2 you can discuss now. Alpha less than K2. So alpha minus K2 less than 0. And here K2 less than beta. So K2 minus beta less than 0. You can write here K2 minus alpha greater than 0, comma K2 minus beta less than 0. Okay. So whenever you multiply both, you can write K2 minus alpha into K2 minus beta plus into minus becomes minus. So you can write here A into f of K2 less than 0. Whenever you multiply both, now you can write this one as f of A into f of K1 into f of K2 less than 0. F of K1 into f of K2 less than 0. For now, I am writing about the graph A greater than 0. Draw a graph. Whenever A greater than 0, it is the upward parabola. Here what I am discussing, K1 plus the, put here first of all alpha and beta are two distinct real roots. Whenever two distinct real roots, you can put here delta greater than 0. Alpha, this is K1. K1 less than alpha. Here middle. So there is no question of, once again you can say there is no relation. Of course, we can say, no, don't write where is minus between where is K2, we cannot see. So there is no relation. Of course, minus between K1 less than minus between 2A you write, because here it is exist minus between 2A comma minus delta by 4. There is no relation of minus b by 2a to K2. We can say k1 less than minus b by 2a. And if you can write a less than 0, the graph is downward parabola. Put here alpha and put here beta. Alpha and beta are distinct roots. Delta greater than 0 you can write. What we have discussed a k1 less than alpha. This is k. This is k1. This is f of k1. Put here k2. So k1 greater than here. That is the concept. Same concept. Here minus b by 2a comma. Of course k1 less than not greater than. Minus b by 2a comma minus delta by 4a. k1 less than minus b by 2a. You can write delta greater than 0. And the condition is that a into f of k1 into f of k2 less than 0 is the condition. A into f of k1 into f of k2 less than 0. Now, of course, there is no model, I think. Even though there is no model, let us discuss, let us finish the question. Of course, location of roots you have finished it. 38, 39, 14 class. In the similar way, in the concept of location of roots, we can discuss level 2 homework. Some questions are there. Yeah, 31, 32, 33. Page number 94, location of roots. 3 questions are there. We can discuss the 3 questions now. Depends upon the concept location of roots. Level 2 homework. Level 2 homework 31, 32, 33. Now I am going to discuss the concept is location of roots. If both roots are first 31 question. If both roots of the equation exceed by put IMP, this is MSET question. Condition both roots exceed by a, that is alpha greater than a and beta greater than a. If both roots f of x I am writing as x square plus x plus a, x square plus x plus a is equal to 0. Whenever both roots exceed by a, so that meaning is simple concept alpha greater than beta greater than k like this. So k is lesser than 2 roots. The concept like this. This is alpha, this is beta, like this is k. So k is lesser than 2 roots. So k is k minus alpha less than 0 and k minus beta less than 0. K minus alpha into k minus beta less than greater than 0 because minus into minus becomes plus f of a into f of a greater than 0. So what is the value? Simply you can put a here. So that is, it is indicating here f of a greater than here. A means k. You can write here that implies I am writing a square plus a greater than 0. So a square plus 2a greater than 0. A you can take common. We can write a into a plus 2 greater than 0. Try to understand properly. A plus 2 into you can write this one a minus 0 greater than 0. So a does not belongs to minus 2 comma 0. A less than minus 2 comma a greater than 0. If option is verified, simply you leave it. A less than minus 2, 31 question, 4th option. Yeah, simply write option 4. Otherwise, you can take delta greater than 0 also. Whenever delta greater than 0, a square minus 4a greater than 0, a into a minus 4, a less than 0, a greater than 4 like this. If greater than 4 is not possible, this is the common one. Now, for this one, delta greater than equal to 0 chance is there. Simply you can leave it. 32nd question now. If both roots of equation lie in the interval, condition. Both roots of equation lie in the interval. So minus 3 less than alpha less than beta less than 4. This is okay. Of course, shortcut you can use. x square minus 2ax. X square minus 2ax plus a square minus 1 equal to 0 is given. This is a given quadratic equation. Now we can say here x square minus 2ax plus 1. Okay. No, x square minus 2ax plus a square equal to 1 and write it. So x minus a whole square equal to 1. X minus a equal to plus or minus 1. X is equal to a minus 1 comma x is equal to a plus 1. Yeah, a minus 1 comma a plus 1. If a minus 1 is small root and a plus 1 is large root, if we think so, smaller less than smaller and greater than greater, like we can use the concept lie in the interval. Use the concept minus 3 less than a minus 1 less than beta, this is 4 greater than a plus 1. So we can use minus 3 less than a minus 1 comma a plus 1 greater than 4. So a greater than 3. Option is there. 31 question. Fourth option given. 30. Now we are going to discuss 32. So integral parts is asking. If minus 2, they can be said minus 2 less than a less. Minus 2 less than a, that's all. A greater than 3 is not correct. If we use this one, a less than, use this one. A minus 1 less than 4 use. A minus 1 less than 4. So we can write a less than 5. So minus 3 less than a minus 1. A minus 1 less than 4. He is asking both roots of the equation lies in the sum of integral parts. Sum of integral parts. Question number 32. A minus 1 greater than minus 3 is correct. A plus 1 less than 4. But we according to here, once we read the question, both roots of equation lies there. Both roots of equation lies in the interval minus that. So we should write this is now this is correct. A plus 1 less than 4. Now we can write minus 3. This is a concept and this is another concept. A plus 1 less than 4 I am writing. So this is a less than 3. Now therefore we can conclude that minus 2 less than a less than 3. He is asking that sum of integral parts. Sum of integral parts means step values. Sum of integral parts. So minus 2 chances are writing minus 1, 0, 1, 2. Example 2. Students try to understand that minus 1.79 step. Minus 1.79 step is minus 2. Minus 2 you should not write, but minus 2 will be getting by applying the real number minus 1.79. So of course between minus 2 3, first you can understand whatever the values exist, minus 1, 0, 1, 2. Minus 1, 0, 1, 2. By substituting the values, whatever the values will be getting, minus 1, minus the values between minus 2 minus 1, plenty real numbers are there. You can apply whenever you are applying, you can get the value minus 2. Whenever you are applying 2.79, 2.93, then you get 2. So the step values here, you can write integral part of step values. Now sum you can write minus 2 minus 1 plus 0 plus 1 plus 2 is equal to 0. 32nd question, 0 first option. Now 33rd question. This is also main question. 32nd question also main second question. Now let us discuss about 33rd question. The expression a minus 2 into x square. A minus 2 into x square plus 2 into 2a minus 3 into x plus 5a minus 6 equal to 0. 0 is not given. The expression is discussed. The expression a minus 2 into x square plus 2 into 2a minus 3 into x plus 5a minus 6 is positive for all real x. Okay. Is positive for all x belongs to R. Plenty of times we have discussed that whenever it is positive for all x belongs to R. First you observe that OF of x square. OF of x square gamma expression. OF of x square gamma expression have same sign. OF of expression gamma x square have same sign for all x belongs to R when delta less than 0. It is the most FA theorem proof also I said. Now you can use the formula delta less than 0. There is no location of Root's concept here. 4 into 2a minus 3 whole square. 4 into 2a minus 3 whole square minus 4 into a minus 2 into 5a minus 6 less than 0. Divide with 4. You can expand this from 2a minus 3 whole square. 4a square minus 12a plus 9 minus of. Let us multiply 5a square minus 6a minus 10a minus 16a minus 6 and minus 2 and plus 12. It is less than 0. That implies next step 4a square minus 12a plus 9 minus 5a square minus 5a square plus 16a minus 12 less than 0. You can write this one. 4a square minus 5a square becomes minus a square and this becomes plus 4a minus 3 less than 0. Multiply with minus both sides, you will be getting a square minus 4a plus 3 greater than 0. You can write as a minus 1 into a minus 3 greater than 0. That the meaning is a does not belongs to 1 comma 3. You can understand this one as a less than 1 comma a greater than 3. According to option 33rd question, he given third. A less than 1 he did not give. Of course it is correct. It is positive for all values. A can be any real number, is not simply here. He given this one option 3. A greater than 3 he given this one as option 3. Okay students, we have completed successfully the theory and the concept, and whatever the sums depends upon the concept and theory. For mains, everything I have discussed. Let us going to discuss the theory bits of CUQ in next class, that is tomorrow.